reason why things sound good or bad. Let's start with the definition. What is consonance and dissonance? Consonance is defined as the impression of stability or repose in sound, whereas dissonance is the impression of tension or clash. Initially, this seems simple, but looking further, it's not so black and white. For example, is this dissonant? I think most people would agree that those are two very dissonant notes. But now, let's change the context. Is that dissonant? To me, that sounds pretty. Those were the same exact two intervals, but played differently and in combination with other notes. This and this. So what does this tell us? Is dissonance and consonance a rigid system where this sounds good and this sounds bad? Or is it a psychological effect based off of our previous experiences and context?
I bet it's the second one.
That's correct, Sawyer. Although there's underlying physics to how each tone sounds, how the listener interprets them is a product of a lifetime of listening to music. This time, I'll use a consonant chord in a dissonant context. That chord probably sounded pretty dissonant to you, even though it was a simple major chord. That might not sound too strange if you've been listening to this your entire life. It might sound pretty odd if you've been listening to this for your entire life.
Each note on a piano is actually just a specific frequency of sound waves. An A4 is a 440 Hz sound wave. A C5 is a 523.251 Hz sound wave. When played at the same time, these tones interact to give us a specific sound.
We can hear the interactions between sound waves really well in this audio. This is two notes that are close but are not quite the same sliding together into a unison sound. Besides generally feeling deep discomfort from this, most people can hear a percussive beating that slows down as the two notes come into tune. So what's happening here? Why is there this beating sound, and why does it sound so unpleasant?
To investigate, let's start visualizing a tone in its simplest form, a waveform to be specific. Here is the fundamental frequency of A on piano, ignoring overtones. That means this sound wave will reverberate your eardrums 440 times per second. Great, your ear says. I can handle this. Now let's add a second note. That sounds like this. Still great, says your ear, but now we can mess with it. So, by tuning up a guitar, increasing the frequency, we can make these notes out of tune with each other. Yes, that is much crunchier. This means the guitar is reverberating your eardrums slightly faster than the piano is. It's useful to think of these waves as being defined as ratios of one another. Then, dissonance can be defined as how complex the ratio is. In that example, we started with the ratio of 440 to 440, 1 to 1, also known as the same note. By the end, our ratio was 472 to 440, a much more complicated interval. This beating we heard before can now be calculated as the absolute value of the difference between the two tones. The distance between the two notes that you heard before was a minor second at the beginning. A minor second has a ratio of 16 to 15, which is a very hard one for your ear to digest. That's why you get this sound. As it slides to becoming in tune, it becomes a simpler ratio. It moves from 16 to 15 just to 1, 16 to 16. Back to one of our early examples of this being the same as this. Let's ask why this works based off of what we just figured out. So, the first time, I just played these two notes. This is called a major seventh and has a complex ratio. When we add this E to it, it yields this nicer sound. That's because there's two consonant intervals inside of that. A perfect fifth and a major third, which obscures this. That's why this is as much a physiological and psychological effect as it is a physical one. To finish this concept in an entertaining fashion, we wrote a little ditty for you. Enjoy! Wait, never mind. 1, 2, 3.
Consonants, 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 dissonance, 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 dissonance. That's surprisingly hard.